Evaluate integral from 0 to 1 pi k starts from 0 to infinity 1 upon 1 plus x to the power 2 to the power k into dx. Here this pi represents the product. First of all, simplify this. So we write integral from 0 to 1. Now the limit of k is from 0 to infinity, so I'll write instead of this limit n tends to infinity 1 upon, now for different values of k I'll simplify this expression and all the terms will be in product, for because this pi represents the product. So we get for k equal to 0 we get 1 plus x, for k equal to 1 we get 1 plus x square, for k equal to 2 we get 1 plus x 4 into so on, and for n we get 1 plus x to the power 2 raised to power n into dx. Here n tends to infinity, so the last term will be 1 plus x to the power 2 raised to power n. Now in the next step, write integration from 0 to 1 limit n tends to infinity. All the terms are same except we divide and multiply by 1 minus x. So if we multiply these two terms we get 1 minus x square, and then multiplying this term with this term we get 1 minus x to the power 4, then multiplying this term with this term we get 1 minus x to the power 16, and this process will continue, and finally we have integration from 0 to 1 limit n tends to infinity, numerator becomes 1 minus x whole divided by, this simplifies, and finally we will get 1 minus x to the power 2 raised to power n into 1 plus x to the power 2 raised to power n, because these terms will simplify up to second last term as 1 minus x to the power 2 raised to power n, and last term here is as it is. And finally we have integration from 0 to 1 limit n tends to infinity 1 minus x whole divided by, now this denominator is again a minus b into a plus b kind of thing, so it becomes a square minus b square, so it becomes 1 minus x to the power 2 raised to power n whole square. In the next step we get 1 minus x whole divided by 1 minus x to the power 2 raised to power n plus 1. Now as we know limits are from 0 to 1, so x is between 0 to 1, dx is also with every term, therefore x to the power 2 raised to power n plus 1 will tend towards 0 because n is approaching to infinity. For example, if I take any number between 0 and 1, let's say it is 1 by 2, and if I take 2 raised to power n plus 1, now as n tends to infinity, so 1 by 2 2 raised to power infinity will give us 1 by 2 whole raised to power infinity, which will tend towards 0. So for every number between 0 and 1 it will always tend towards 0. So therefore limit starts from 0 to 1, we get 1 minus x into dx, and on integration we get x minus x square by 2, integration from 0 to 1, applying the upper bound and lower bound we get 1 minus 1 by 2 minus 0, So 1 by 2 is the answer.